we present DeGauss, dynamic static decomposition with Gaussian splatting for distractor-free 3D reconstruction. Recent advances in neural radiance fields and 3D Gaussian splatting have enabled scalable 3D scene reconstruction and high-quality novel view synthesis from image collections. However, these methods struggle to generalize to casual captures containing dynamic elements, such as moving objects and humans. In such cases, dynamic content is often modeled as view-dependent artifacts, resulting in a lot of floaters in the reconstructed scene. This limitation is further amplified in egocentric videos, which is a rapid-growing data source with wide availability of VR and AR devices. The egocentric data often features unique challenges as highly dynamic user activities, large scene deformation, and constant occlusions. These challenges lead to a reconstructed 3D Gaussian with heavy floaters. The key question we would like to address in this work is to reconstruct clean, distractor-free scene for these challenging real-world captures. For distractor-free scene modeling, several works leverage reconstruction loss residuals and semantic features to identify and mask dynamic content, as transient regions often exhibit higher reconstruction error. These methods as spotless splats achieve state-of-the-art distractor-free modeling for image collections. Moreover, several self-supervised methods aim to jointly model dynamic and static elements to prevent the update of static branch in dynamic regions, such as NW and neural diff. When applying to egocentric data, methods as spotless splats, that are heavily reliant on initialization, would gradually overfit to moving elements instead of masking them out during training iterations. As a result, it would lead to a reconstructed scene with heavy floaters. For existing self-supervised methods as neural diff, they face balancing issue, where the dynamic foreground would dominate overall reconstruction, leading to an under-reconstructed background. To address these challenges, we propose DeGauss, dynamic static decomposition with Gaussian splatting for distractor-free 3D reconstruction. It robustly handles the challenging egocentric video input, reconstruct distractor-free and high-quality static scene via accurate dynamic static decomposition. Our key insight is to leverage the complementary strengths of dynamic and static Gaussians for coordinated optimization for dynamic scene reconstruction. Specifically, we model the scene with foreground dynamic Gaussians and background static Gaussians in separate branches. The foreground Gaussians, embedded with mask attributes, employ the hexplane encoder and MLP decoders to predict updated Gaussians. The complementary update of foreground and background Gaussians are controlled with the probabilistic composition mask, rasterized by foreground dynamic Gaussians, while the reconstruction loss between the composed render and the input images is minimized. This decoupled background-foreground formulation allows flexibility during training and better handles local minima. We additionally introduce a brightness control module to prevent the static dynamic ambiguities caused by varying illuminations. Compared to baseline methods 3DGS and spotless splats, our proposed DeGauss creates distractor-free scene with fine details and smooth depth geometry. We demonstrate the wide generalizability to various egocentric dataset, specifically ARIA Digital Twin Dataset, ARIA Everyday Activities Dataset, Hot 3D Dataset, and Epic Field Dataset. DeGauss robustly decomposes dynamic and static elements and creates distractor-free 3D scene. In addition to dense video, our method also seamlessly generalizes to image collections, robustly decompose dynamic static elements. Compared to previous SOTA methods on NeRF on-the-go dataset, our methods creates higher quality render and better depth geometry accuracy. Moreover, for dynamic scene modeling with DeGauss, we obtain a decoupled foreground dynamic Gaussian and background static Gaussian hybrid representation. Compared to 4DGS, our method renders at higher FPS, as our method largely reduces the number of Gaussians in the computationally expensive deformation stage with dynamic static decomposition. In zoomed-in view, we show that our method reconstructs finer static details and mitigates the oversmoothing in modeling dynamic Gaussians with our dynamic static decomposition, which leads to consistently better perception score on test set. In summary, we propose DeGauss, dynamic static decomposition with Gaussian splatting for distractor-free reconstruction. It is a simple and robust self-supervised framework that leverages dynamic static Gaussian splatting to effectively model and separate dynamic elements from input scenes, simultaneously achieving state-of-the-art distractor-free static reconstruction and high-quality efficient dynamic scene representation.